Now let's see this question, and this is very beautiful, interesting question. Tell me the answer. The question is saying, assume this question mark means not in this place. Okay, see, this question mark means what? Tell me. Tell me what this question mark means. This question mark means 2 is not in this place. Means 2 is not in second place. This means 2 not in second place. Not in second place. Okay, similarly, tell me what this means. What this means, or tell me what this means. This means n is not in nth place. N not in nth place. Did you understand the question? But remember, where is k? Tell me where is k? K is in the first position. K in first position. Yes or no? K in first position. Agree or not? K is in the first position. And where is 1? 1 in the kth position. 1 in kth position. 1 is in the kth position. Did you understand the question? Please tell me. Please tell me, did you understand the question? The question is saying that this question mark means not in this place. For example, this means 2 is not in second place. 3 is not in third place. N is not in nth place. But remember, K is in the first place and 1 is in the kth place. Okay, so now tell me the answer. What the answer will be? The question is simple. It's like this. You have total k, n elements are there total. Total there are n positions. 1, 2, 3 and so on. There are total n positions. K, n. Okay. Now the question is simple. The question is saying that the k is coming here. This is fixed. K is coming here. This is fixed. The question is saying that k is coming here and 1 is coming here. This is also fixed. But here 2 should not be there. Here 2 should not be there. Here 3 should not be there. Here n should not be there. Did you understand this? Please tell me. Is this clear? What I'm saying? So what is your final answer? See, this k is already fixed. This k is in the first position. This is fixed. This 1 is in the kth position. This is fixed. So the derangement of the remaining elements. So your answer will be what? Answer will be derangement of the remaining elements. The answer will be derangement of the n minus 2 elements. Because this is fixed. 1 is in the kth position, that is fixed. 1 cannot go anywhere. Similarly, k cannot go anywhere. K is here. They are changing their position. They are changing their position. The remaining people are deranging. The derangement of the remaining people. Is this point clear? Can I say answer will be dn? Can I say answer will be dn? Is this correct? Like if I say, can I say answer will be dn? The answer will not be dn. Why? The answer will not be dn. Why? Tell me why. Because when you say dn, then 1 can go to nth position also. Agree with me? See, when you say dn, then 1 can go to second position. 1 can go to third position. Agree with me? Is it allowed? If you say answer is dn, then 1 can go to third position. 1 can go to third position. Is it allowed? Is it allowed? That is not allowed. 1 should go to here and k should come here. The remaining people should derange. So the answer will be what? 1, k are fixed. So the remaining n minus 2 people should derange. Please tell me, did you understand this? This is very beautiful question. I will tell you why. Okay, because when you see the proof of recurrence relation for derangement, this will be useful. So just take it as a note. Okay, please take it as a note in your notebook. Take it as a note. Means if you do this, you have total n elements. You have total n elements. So there are total n elements. N elements derangement you want. You want n elements derangement such that this is fixed, that 1 goes to kth place and k goes to 1th place. Okay, this is fixed. So tell me the answer will be what? You want derangement. You want derangement such that 1 is going to kth place and k is going to first place. So the answer will be what? In this case, answer will be what? That will be d n minus 2. Is this point clear? Please tell me. Did you understand this point? The answer will be d n minus 2. Because this is already fixed. They are doing the fixing. One is saying that I will go to the kth place. It's like they are shaking hands. One is going to kth place, k is going to first place. Okay, so they are already partners. They have already done the partnership. So we want derangement. So the remaining n minus 2 elements should go to, I can say, should be homeless. So the derangement of the remaining people. Did you understand this note? Please give me yes or no. Because this is important. So that is the reason I am saying. Simple. Okay, now let's see this question. Okay, how many derangements? Actually, in this question, let me ask you derangements. How many derangements are there? But the condition is given. What is the condition given? Condition is given that 2 goes to first place, but 1 does not go to second place. Did you understand this? Nice question. See, did you understand this? The question is saying, these are the places. These are the total n people. These are the total n people. 1, 2, 3, 4, and so on n. The question is saying that we want derangement. Okay, we want derangement. We want derangement. But remember this type of derangement where 2 goes to here. This 2 is fixed. If I put 2 here, can I say 2 has deranged? If I put 2 in the first place, can I say this 2 has deranged? Can I say 2 has deranged? Yes. Okay. But there is another condition. You should not put 1 here. Okay. Here, 1 should not come. Did you understand? That 2 is going to 1's house. 2 is going to 1's house. But 1 should not go to 2 house. See what we are saying. We are saying that 2 should go to 1's house, but 1 should not go to 2's house. Okay. Now, how many derangements are there? We want derangement. This type of derangements we want. So let's solve this question for small values. For example, let's solve this question for n equal to 5. If you have n equal to 5, or maybe if you have n equal to 4, 2 should be here. This 2 is fixed or not? Tell me. This 2 is fixed or not? Yes, this 2 is fixed. Okay. And 1 should not be here. Here, 1 should not be here. Okay. You understood the question, right? Now, what should be the answer? Let's find out. See, 2 should be in the first place, but 1 should not be here. So here either who can come? Who can come? This 1 will go here or here. So in the second position, let's assume 3 is coming. Then this will happen if 3 is coming here. Or what you can do? Or what you can do, tell me. Either you can do this, or what you can do? You can put 4 here. Okay. You can put 4 here. Then you can do this. Or what you can do? Anything else possible? Is anything else possible? Only these are possible, right? Did you notice? Only these are possible. So the answer will be what? These are the only possibilities. Did you understand the question? Please tell me. These are the only possibilities. So if you have, then now something interesting, something very interesting. Please focus here. Something very, very, very interesting is coming. Can you notice this is the derangement of 1, 3, 4. Can I say it's like derangement of 2 elements? Derangement of 3 elements. Can I say it is like derangement of 3 elements? Okay, it is like derangement of 3 elements. You know, derangement of 3 elements is also 2. Okay, this is also 2. Derangement of 3 elements is also 2. What I want to say, let me tell you. See, something very interesting is coming. So just focus here. What I'm saying is, you have already decided that this 2 will go to 1's house. Okay, 1's house. This 2 is already going to 1's house. Please focus on this. This is very interesting and you will appreciate it. This is interesting also. 2 is going to 1's house, but 1 should not go to 2's house. 2's house. Okay. So this type of derangement we want. We want this type of derangement. This type of derangement. Okay. So you tell me what I'm doing. See, something interesting I'm doing. What I do, for a moment, I give this 1's house to 2. Okay, means 2 has already taken the 1's house, right? Yes or no? 2 has already taken the 1's house. Means 2 has already taken this. Now I am saying that 1 should not be here. 1 should not be here. Okay, and the remaining people should derange, but 1 should not be here. What I can do, something smart, something trick. There is a trick here. What I do, for a moment I say that this is the original position of 1. This is the original position of 3. This is the original position of 4. This is the original position of n. Okay, this is the trick I am playing. For a moment, just wait. For a moment I am saying this is the original position of 1. This is the original position of 3. This is the original position of 4. This is the original position of n. Now if I derange, then will 1 go to second house? Now if I derange, okay, this trick I am playing this trick. I am saying that this trick is there. Okay, assume these are the original positions. Assume these are the original positions. Please understand. Assume these are original positions. Assume these are original positions. Now if I derange, now if we derange, then will 1 go to second house? Will 1 go to 2's house? Now if we derange, will 1 go to 2's house? Tell me, simple question I'm asking. Did you understand the trick? Now if we derange, then 1 will not go to 2's house. And this is what we want. 1 will not go to 2's house. The answer will be what? Did you understand this trick? Very beautiful trick, right? Is there anyone who appreciating this trick? Did you understand this trick? See, this is what we want. Please understand. We want 3 things. We want what we want. We want derangement of all elements. Derangement of all elements. Please understand. This is what we want. Derangement of all elements. And 2 should go to 1's house. 2 should go to 1's house. And 1 should not go to 2's house. 1 should not go to 2's house. Okay, we want this. This is what we want. Right? Agree? This is what we want. That now what I can do, this trick I am playing, that for a moment, this is like, okay, 1, 2, 3, 4, and so on, n. What I'm saying that this is fixed. This is a fixed. Okay, so don't change it. Now what I'm saying, for a moment I'm saying this is the original position of 1, this is the original position of 3, this is the original position of 4, this is the original position of n. See, this trick, this is just a trick, nothing else. Assume this is the original position. Assume these are original positions. Okay, assume these are the original positions. These are the original positions. Okay, this is what I'm assuming. Of course, this is a trick. Remember, this is a trick. Clever trick. This is just a clever trick. Okay, now you tell me. This is just a clever trick. Now you tell me. Now if I derange, then what will happen? Now if I derange, then what will happen? Please tell me. Now if we derange, now if we do dn minus 1. Okay, now if we derange, अर्थात now if we derange, then what will happen? Then 1 will not go to 2's house. Then 1 will not go to 2's house. Yes or no? Then 1 will not go to 2's house. Is this point clear? Let me know. Okay. So very simple. Understood this? So finally answer will be what? So your final answer, what that will be? Your final answer will be D n minus 1. Understood? Yes or no? Bhargav is saying, I'm new here. Can I follow engineering mathematics and discrete mathematics from free courses or subscription is needed? Yes, discrete mathematics and engineering mathematics are free for everyone. Complete discrete mathematics, complete engineering mathematics, these are free for everyone. You can follow without subscription. Okay, on GoClasses website, on GoClasses app, you can follow discrete mathematics. Complete discrete mathematics is free. Similarly, complete engineering mathematics is free. Okay, anyway, so please tell me, everyone, please tell me, did you understand this question? This previous question, did you understand? This question, final answer is what? The final answer is D n minus 1. So we have seen two questions. Okay, let's see. We have seen total two. This is interesting. We have seen total two possibilities. This is your question that, see, you want derangement. This is 1, 2, 3, and so on n. We have seen two questions. One is, what is the type 1? What is the type 1 derangement? See, what is the type 1 derangement? Okay, one type of derangement, what is that? That 1 goes to 2's house, 2 goes to 1's house. Okay, 1 goes to 2's house and 2 goes to 1's house. 1, 2, 3, and so on n. Means 2 goes here, 1 goes here. And the remaining are deranged. The remaining deranged. So the answer will be what here? Here the answer will be D n minus 2. This is simple. And what is the another derangement? What is another derangement? The type 2 derangement. What is that? Tell me. The type 2 derangement. What is that? That is like this. That 1, 2, 3, 4, and so on n. So see, notice 2 goes here, but 1 does not go here. Here 1 does not go. Okay, here 1 does not go. Here 1 does not go. So the answer will be here. In this case, answer will be Dn minus 1. Yes or no? In this case, answer will be Dn minus 1. Here answer will be Dn minus 2. Understood this? Can I say everyone here understood this? Please tell me. Did you all, everyone, did you understand this point? Now let's see the final question. This is derangement recurrence relation. Now you will find it very interesting. This is the derangement recurrence relation. Find the recurrence relation for derangement. Means you want to write dn in terms of what? You want to write this dn in terms of dn minus 1, dn minus 2, something like that. Okay, so is this clear? We want derangement recurrence relation. For derangement, for dn, we want the recurrence relation. So what we want to do? We want to write this dn as a function of previous terms, as a function of previous terms, as a function of previous terms, also as a function of n. Is this point clear? This is what we want. We want to write dn in terms of previous terms and in terms of n. This is what we want to do. Okay. This is your Kenneth Rosen question also. This same question you can find in the Kenneth Rosen exercise 8.6, question number 18. Recurrence relation for derangements, for the number of derangements. So let's find it. We will prove this recurrence relation. Okay, let's find it. See, you want dn, total n elements you have, you want dn. This is what you want. Okay, so this dn, this is what you want. And total, how many elements you have? Total, you have total n elements. 1, 2, 3, 4, and n. This is what you have. So we want dn. We want to write this dn. What will be dn? Let's see. See, if you are doing the dn, what are the possibilities for 1? What are the possibilities for 1? In the derangement, what are the possibilities for 1? Let's focus on 1. Okay, we want dn. Remember, this is what we want. Now, if we want this, let's focus on 1. Let's focus on this element 1. Let's focus on this element 1. Okay, we want the derangement of n elements. Let's focus on this element 1. This element, let's focus this element. So tell me, what are the possibilities for 1? For this element, what are the possibilities? Either it can go here, or it can go here, or it can go here, or it can go here. How many possibilities for 1? See, 1 can either go to second 2's house, 1 can go to 2's house, or 1 can go to 3's house, or 1 can go to 4's house, or 1 can go to n's house. Yes or no? So total, how many possibilities 1 have? So let's focus on 1. So I can say n minus 1 choices for 1. Agree? Let's focus on this element. Completely focus on this element. So can I say these will cover all the derangements? Do you agree with me? Am I covering all the derangements? I want all the derangements. All derangements. So these are covering all derangements, right? Yes or no? Agree? These are covering all derangements. We are covering all the derangements, because in any derangement, either 1 will go here, or 1 will go here, or 1 will go here, or 1 will go here. So like this. So these are covering all the derangements. We have covered all the derangements. Okay, so let's focus on 1. Now you tell me, if you are focusing on 1, there are 2 cases. See, there are 2 cases. Okay, either 1 is going to some house, either that person is coming to 1's house. So there are 2 cases. See, let's assume 1 is going to kth house. Let's assume 1 is going to kth house. Okay, where 1 is going, or I can say, for example, 1 is going to 2's house. Let's assume 1 is going to 2's house. Then what are the possibilities? Please tell me. 1 is going to 2's house. How many possibilities? There are 2 cases, either case 1 or case 2. What are those? See, 1 is going to 2's house, and 2 is also coming to 1's house. Either this possibility is there, or what possibility is there? 1 is going to 2's house, but 2 is not going to 1's house. Yes or no? Agree with me? Do you agree with me? Please tell me. 1 is going to 2's house, and 2 is going to 1's house. Either this is possible, or what is possible? 1 going to 2's house, but 2 is not coming to 1's house. Is there any other possibility? Is there any other possibility? If 1 is going to 2's house, is there any other possibility? No. Only these 2 possibilities are there, case 1, case 2. What will be the answer in the first case? What is going to be the answer in the first case? Means, remember, 1 going to 2's house. 1 going to 2's house. There are 2 cases possible. Either case 1 possible or case 2 possible. Case 1 is this, that 1 is going to 2's house and 2 is going to 1's house. So in this case, how many derangements? In this case, how many derangements? dn minus 2. In this case, dn minus 2. The remaining n minus 2 people will derange. So very simple. Okay. And what is the another case? Another case is 1 is going to 2's house, but 2 is not going to 1's house. In this case, how many derangements? In this case, dn minus 1 derangements. We have already seen. We have already seen this, right? Yes or no? So very simple. This we have already seen. What is the trick here? Tell me, what is the trick here? dn minus 1. What is the trick here? Please tell me, what is the trick here? See, this is the trick, that 1 will go to 2's house. For a moment, you assume that this is 2's house. For a moment, you assume that this is the 2's original position, this is the 3's original position, this is 4 original position, and this is n's original position. So then you derange. Then you derange. So your answer will be dn minus 1. Did you understand? Please tell me. Okay. So this is the point. So in this case, when 1 is going to 2's house, the answer will be what? In this case, the answer will be what? Means 1 is going to 2's house. In this case, how many this type of derangements are there? How many such derangements? How many such derangements? Tell me. How many such derangements? Tell me. 1 is going to 2's house. How many such derangements? that will be dn minus 2 plus dn minus 1. Okay, dn minus 2 plus dn minus 1, because 1 is going to 2's house, either this will happen or this will happen. Either this will happen or this will happen. Do you agree with me? See, 1 is going to 2's house, either case 1 will happen or case 2 will happen. Agree? Is this point clear? Either case 1 will happen or case 2 will happen. If case 1 happens, then dn minus 2. If case 2 happens, then dn minus 1. So total this many derangements will be there. This type of derangements, that will be this. Now total how many derangements will be there? Total derangements, what that will be? See, total derangements, that will be either 1 will go to 2's house, or 1 will go to 3's house, or 1 will go to 4's house, or 1 will go to n's house. In every case, what is the answer? In this case, dn minus 1 plus dn minus 2. In this case, dn minus 1 plus dn minus 2. In every case, you are getting this answer. Yes or no? Agree? In every case, you will get this answer. Do you agree so far? Please tell me. Total derangements will be either this will happen, or this will happen, or this will happen, or this will happen, and so on. So either this will happen or this will happen. So remember, I am saying that either this will happen or this will happen, or this will happen, or and so on, this will happen. Please tell me, did you understand? So total how many derangements will be there? Remember, whatever case you take, please understand. See, whatever case you take, these are the people. 1 here, 2 here, 3 here, okay, and here. If you consider this case, let's assume this is the K's house. If you consider this case, 1 is going to K's house. How many possibilities? Please focus. 1 is going to K's house. How many possibilities? 1 is going to K's house. There are 2 cases. This is going to K's house. 1 is going here. So there are 2 cases. The case 1, what are the case 1 and what are the case 2? Please tell me. What is the case 1? See, case 1 is 1 is going to K's house and K is going to 1's house. Right? 1 is going to K's house and K is going to 1's house. In this case, how many derangements? In this case, the remaining people will derange. In this case, the remaining people will derange. And what is the case 2? Case 2 is 1 is going to K's house, but K is not going to 1's house. In this case, how many derangements? In this case, how many derangements? In this case, dn minus 1 derangements. Okay, so either case 1 will happen or case 2 will happen. Either case 1 will happen or case 2 will happen. So how many such derangements? How many such derangements? Tell me. How many such derangements? That will be dn minus 1 plus dn minus 2. Yes or no? How many such derangements? That will be dn minus 1 plus dn minus 2. Now did you understand this? I want total derangements. I want total derangements. So either 1 can go here, or 1 can go here, or 1 can go here, or 1 can go here. Either 1 can go to 2's house, or 1 can go to 3's house, or 1 can go to 4's house, or 1 can go to n's house. In every case, this value you will get. Either this will happen, or this will happen, or this will happen, and so on. So tell me your final answer. Total derangements, what that will be? That will be n minus 1 multiplied by dn minus 1 plus dn minus 2. Because these many choices one has. Did you understand the proof and did you enjoy it? Please tell me, did you understand the proof and did you enjoy this proof? Please tell me, did you love this proof? Before learning this proof, did you by heart this formula? I have seen many students, they by heart this formula, but the proof is beautiful. let me tell you, the proof is beautiful. Okay, the proof is actually beautiful. So I hope you understood that this is how we can prove it. Okay, so this video I will put on the YouTube channel, on the GoClasses YouTube channel. I will put this video. Please comment on that video. Did you find this proof? I can say beautiful. Did you understand this proof? Okay, two things you tell me in the comments. Did you understand this proof, and did you find this proof beautiful? Okay, please tell me. So this is your final proof. So remember this, remember this, remember this. D of n, that is equal to n minus 1 multiplied by dn minus 1 plus dn minus 2. This is your answer. Okay, yes or no? See, this is your proof. Tell me, what are the base conditions? What is D1? How many derangements of one element? Can you derange one element? Can you derange one element? You cannot derange one element. D1 is 0. What is D2? What is D2? What is D2? Derangement of two elements. That is this. These are the base conditions. So now you tell me, what is D3? D3 is 3 minus 1 multiplied by D2 plus D1. That will be equal to what? 2. That will be 2. Okay, what will be D4? Please tell me D4. D4 will be 3 multiplied by 2 plus 1. That will be 9. What is D5? D5 will be 4 multiplied by 9 plus 2. That will be 44. Okay, like this, now you can easily find anything. Yes or no? So this proof you understood, this formula you understood. So now you can easily find. So this you note it down. Okay, two things you note down. What? The one thing is this formula, n minus 1 multiplied by dn minus 1 plus dn minus 2, and the proof. And the proof. And the base conditions also you can write. D1 is 0, D2 is 1. These are the base conditions. So this complete thing you note down in your notes. Okay, simple. Understood? Please tell me, shall we move on? Now, let's see something interesting, something very interesting from the previous formula. From this formula, now we are going to get an interesting result. And this is Kenneth Rosen question. Let's check it out. What this question is saying? Kenneth Rosen exercise 8.6, question number 21. This is question number 21. Okay, the question is saying that for which values of n, dn is even. This question, very simple question, and very interesting result we are going to get. What is the interesting result? See, number of derangement is odd if and only if number of elements is even. Did you understand this? See, you already know what is D1. Tell me, what is D1? Please tell me, what is D1? D1. What is that? That is 0. D1 is 0. Can I call it even? And can I call this odd? D1. See, D1 means 1 is odd, right? What is D2? You already know D2. D2 is 1. That is odd. What is D3? D3 is 2. That is even. What is D4? D4 is 9. That is odd. What is D5? D5 is 44. That is even. Find out what is D6. Find out what is D6. Remember, this point we already know. This formula we already know. We have seen the proof also. This dn means n minus 1 multiplied by dn minus 1 plus dn minus 2. This we already know. So tell me, what is D6? D6 will be 5 multiplied by D5 plus D4. So tell me, what is this value? Calculate this value and tell me the answer. That will be 265. That will be 265. Can you notice this is odd? So can you notice, when you have even number of elements, derangement is odd. Odd number of elements, derangement is even. Even number of elements, odd derangements. Odd number of elements, even number of derangements. Even number of elements, odd number of derangements. Odd number of elements, even number of derangements. Okay, how can you prove it? Now, how can you prove it? So this is what we need to prove. Please understand, we need to prove this. What we need to prove that? We need to prove that D even will be odd, D even will be odd, and D odd will be even. Can anyone tell me how to prove it? Can anyone tell me how to prove it? With induction, we can prove. With induction, we can prove. See, proof by induction. You already know. What we know? Tell me what we know. We already know what? See, we already know that dn is equal to what? Dn is equal to n minus 1 multiplied by dn minus 1 plus dn minus 2. Okay, this is what we know. And we also know the base cases. We also know the base cases. This we already know. Now we can prove by induction. What we need to prove? First you tell me. First you tell me what we need to prove. You need to prove that D even is odd and D odd is even. This is what we need to prove. So how to prove it? We can prove by induction. Proof by induction. You can prove it by induction on n. Inductive proof. You can prove by induction on n. What I can do? See, you already know the base cases. What are the base cases in the proof by induction? In the proof by induction, what are the base cases? Please tell me. What are the base cases in the proof by induction? The base case you already know. The base case satisfied, right? The base cases are satisfied. They satisfy or not? D1 is even. Does it satisfy what we want to prove? This is what we want to prove. We want to prove that D even is odd and D odd is even. Is it satisfied by the base case? Is it satisfied by the base case? Yes, it is satisfied. D2 is 1. That is also satisfied. Even D3, you know D3 is 2. That is even. That is satisfied. You know D4 is 9. That is odd. That is satisfied. So I can say base case satisfied. I can say base case are satisfied, right? Yes or no? These small cases are satisfied. Base cases are satisfied. Okay. Now, remember we are proving by induction. This we are proving by induction. So base case is already satisfied. So let me just write it. This is what we want to prove. We want to prove that D odd is even and D even is odd. This is what we want to prove. Okay. Now, base case satisfied. The proof is by induction. We are doing the proof by induction. In the proof by induction, already base case satisfied. What is the first step? The first step is base cases satisfied. Okay. Base cases are already satisfied. Now, assume that till n minus 1, it is satisfied. Assume that this happens till n minus 1. This is the second. What we do? We assume that, assume from 1 to n minus 1, assume from 1 to n minus 1, 1 to n minus 1, this is a true. Okay, let's call it P. Let's call it P. I am calling it P. So assume that from 1 to n minus 1, I can say this P is satisfied. This P is true. Now what we need to do? Tell me what we need to do. We need to prove that for n also it will be true. Now we need to prove, that for n also P is true. For n, P is true. This is what we need to prove. Yes or no? Now prove that for n also this statement is true. So tell me what you will do for n. For n, tell me. See what I am saying. I am saying that this we have assumed. We have assumed that this is true. Okay, that this is true from n to n minus 1. This. Okay, this is true till n minus 1. Now what we need to do? Now we need to prove for n. Now we need to prove it for n. So what are the cases? Either n can be even or n can be odd. Case 1. What is the case 1? If n is even. Tell me, if n is even, then what will happen? Case 1, if n is even, then what will happen? Means d even. dn means d even. If n is even. So that means you already know this formula, you already know. dn minus 1 plus dn minus 2. So tell me, if n is even, what this value will be? If n is even, what this value will be? This value will be what? If n is even, this value will be odd. Okay. And if n is even, what this value will be? See, this will be d odd, and this we have assumed that this is a, see, this is even by assumption. This is even by assumption. Agree? Agree or not? This is even. This is even by assumption. This is even by assumption. And what is this? This is d even. This is odd by assumption. Yes or no? This is d even and this is odd by assumption. This is odd by assumption. So tell me, if n is even, then what will happen? So this case 1, if n is even. So in this case, what will happen? D even, that will be equal to odd multiplied by odd plus even. What is odd plus even? That is odd. So odd multiplied by odd, what is that? Odd multiplied by odd, that is odd. Okay, did you understand? So what we have proven, tell me. So what we have proven? So hence proved. So hence proved that D even is equal to odd. Okay, D even is equal to odd. This we have proven. Okay, similarly, we need to prove if n is odd. Similarly, we need to prove if n is odd. Then what will happen? If n is odd, now what will happen? Now you can notice that this will be even, whatever it happens. dn minus 1 plus dn minus 2. See, this will be even, right? Even multiplied by anything is even. Agree? Okay, this will be even and this can be anything. This can be anything. Even multiplied by anything, that is even. So what we have proven? Even multiplied by anything is even. So finally, what we have proven? So hence proved. Okay, we have proven that D even is odd and D odd is even. Hence proved. Please tell me. Simple, right? Yes or no? Very simple. The proof was very simple. The proof is also very simple. So D even will be odd and D odd will be even. So this is what we have proven. Is this clear? So remember this point. So you can just, if you want, you can remember this point that dn is even if and only if, this is if and only if n is odd. You can also say that dn is odd if and only if n is even. Okay, this is your point. And you also remember this recurrence relation, n minus 1 multiplied by dn minus 1 plus dn minus 2. Understood? Please tell me.